Palm-based esters are widely used in the food, personal care, and industrial sector due to their excellent properties such as high oxidative stability, low volatility, and good lubricity. The production of palm ester typically involves a chemical reaction between palm oil and the alcohol, followed by a separation process to obtain the desired ester product. Scaling out the production of palm-based ester using a reactor system involves increasing the production capacity of the process from a laboratory or pilot scale to the larger industrial scale. This process involves several steps, including process design, equipment selection, process optimization, and safety consideration. Process design involves determining the optimal reaction condition such as temperature, pressure, and reactant concentration to achieve the desired ester product yield and quality. Equipment selection involves choosing the appropriate reactor type and size as well as other necessary equipment such as pump, heat exchanger, and separator. Process optimization involves fine-tuning the process parameter to maximize the production efficiency and minimize waste generation. Safety consideration include identifying and mitigating potential hazards associated with the process such as fire, explosion, and chemical exposure. Number 4 is the separation of material system setup. The first section is set the raw material mixture is typically involved and glycerol blending in the separation process can be carried out using in the process. The reactor system ratio of the raw material used depend the other separation specific production capacity phase depends on the specific purified and marketing a series of the raw materials are usually installation column to a reaction condition such as temperature and the pressure are maintained impurities and ensure product quality and purity easily of the reactor system setup. The next step is to the setup the various raw materials preparation. This typically next, the number 5 quality recovery and the process sample are taken and glycerol phase is usually recovered and processed for use in other application. The alcohol may also be recovered quality control is back into the process. Recycling the alcohol reduce the cost of the process and minimize waste. The number 7 is the packaging. Next, the number 5, the recovery and recycling the palm-based ester glycerol phase is usually recovered and processed for use in other applications. The alcohol may also be recovered until they are ready to recycle back into the process. The recycling the alcohol reduce the cost of the process and minimize waste being produced and its next the number 5 recovery.
So for the next part, I'm going to share about the esterification that occur in the palm ester reaction system. So let me brief about the esterification first before we going deeper. Esterification is a reaction in which alcohol reacts with an acid to form an ester and water as the product. So the reaction usually requires a catalyst such as an acid or an acid derivative or Lewis acid. Esterification also typically carried out under reflux condition where the mixture is heated and the vapors are condensed and returned to the reaction vessel. The reaction usually conducted in the presence of inert atmosphere to prevent oxidation or side reaction. For your information, esterification is a reversible reaction. That means the reaction can proceed both forward or backward reaction. The equilibrium between the reactant and the product, or in this case, between acid and the alcohol, can be influenced by a few factors such as temperature and the concentration. So let's go in deeper into the pump ester reactor system reaction. Usually the acid and the alcohol used are palm fatty acid distillate, or we call as palmitic acid, and the alcohol used is methanol. The reaction occurs in the temperature between 50 until 70 degrees Celsius under reflux condition. The catalyst used usually sulfuric acid, hydrochloric acid, or Lewis acid such as zinc chloride solution. Next, for the mechanism of the reaction, in the presence of an acid catalyst, the palmitic acid will protonated by the catalyst, generating a reactive species called an acylium ion. So the protonated palmitic acid donates a proton to the acid catalyst, forming an acylium ion. So after that, the methanol will act as a nucleophile, attacking the carbonyl carbon of the acylium ion. So this attack results in the formation of tetrahedral intermediate. After that, a proton transfer occurs from the tetrahedral intermediate to the acid catalyst, will regenerate the catalyst and forming a carbocation intermediate. The carbocation intermediate formed in the previous step undergoes an elimination reaction where a molecule of water will be eliminated. So the product form will be the ester, or in the reaction methyl palmitate will be produced.
Okay, next is problem raised from the process. As we know, they might have some problem in scaling up the process of pump-based ester using reactor system. It can be difficult to maintain consistent product quality and purity at larger scales. This is because there are small variation in reaction condition, such as temperature, pressure, mixing speed. It can have a greater impact on the final product at larger scales. As a result, additional process control measures and quality assurance procedures may be necessary to ensure that product meets the desired specification. Another problem of scaling up the process of pump-based esters using reactor systems, it is challenging and potentially more costly. The lack of preliminary testing could lead to issues with product quality, yield, and equipment performance, which could result in significant loss for the manufacturer. Additionally, the lack of optimization at a smaller scale could lead to the need for more expensive equipment and processes at larger scales, which would increase the overall cost of the production. The last problem is the potential for environmental impact. The production of pump-based esters requires a significant amount of energy and resources, including water, electricity, and raw materials. Additionally, the cultivation of palm oils, which is a key raw material for palm-based esters, has been associated with deforestation, habitat destruction, and other environmental issues. As a result, it is important to consider the environmental impact of palm-based ester production and to take steps to minimize any negative impact. This may include using renewable energy sources, implementing sustainable farming practices, and minimizing waste and pollution.
So for the problem that we raise from the process, we have certain way to improve it. First of all is scale up methodology. It's important that we must choose the right scale up methodology that suits the process. It includes geometric scaling, maintaining constant heat transfer rates, or matching dimensionless parameter. Consult an expert to determine the most suitable approach for your specific process. Second is process parameter optimization. Optimize critical process parameter that ensure consistent product quality at larger scale. Factors like reaction temperature, reactant concentration, reaction and catalyst amount may need adjustment during the scale-up. The reactor design also must be optimized to accommodate larger volume while maintaining efficient mixing and heat transfer. Efficient reactor design can help maintain consistent reaction condition and minimize variation in product quality. The number 4 of the way to solve the problem is pilot scale studies that are also important. Before scaling up to full production, this enables testing and process on a smaller scale, assisting in identifying and resolving any difficulties or bottleneck before moving to larger reactor. Designing an efficient and robust production or system also will happen. For environmental problem as well, the process must follow the green chemistry principle. It includes minimizing the use of hazardous substance, selecting environmentally friendly solvent and catalyst, and designing process with minimal environmental effect. Last but not least is establish a robust environmental monitoring program to track and measure the impact of the scaling process. To guarantee compliance with rules and spot areas for improvement, monitor air pollutants, wastewater quality and other pertinent environmental indicator on a regular basis. If we alert to the point that I told, we can avoid the problem state in the previous slide from happening.